Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. After the webinar is over, please take our survey to tell us how we've done. Throughout the presentation, you can network with others or submit questions to the speakers in the box next to the slides. Download resources from the folder icon. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Email Us. If you experience any technical issues today, please refresh your browser by hitting F5 for a PC or Command-R for Macs, or email webinars@bmpmedia.com for one-on-one support. And now I'm excited to turn it over to today's moderator.
Good afternoon and welcome to this webinar, What's Up with Lithium-Ion Batteries. This event brought to you by Mission Critical is sponsored by Eaton. I'm your moderator, Caroline Fritz, editor of Mission Critical. Today's presenter is Ed Spears, Product Marketing Manager for Eaton's Critical Power Solutions Division Raleigh. A 35-year veteran of the power systems industry, Ed has experience in UPS systems testing, sales applications engineering and training, as well as working in power quality engineering and marketing for telecommunications, data centers, cable television, and broadband public networks. Don't forget to submit your questions, and later in the program, our presenter will address as many as possible. Today's event is being recorded and archived on missioncriticalmagazine.com. And now I'm excited to turn it over to today's presenter, Ed Spears. Welcome, Ed.
Thank you, Caroline. Welcome, everyone, to our little discussion on lithium-ion batteries for UPS applications. Let's take a look at the overview here. The topic of lithium for UPS has become intensely energetic over the last couple of years, especially. Almost every client we have is asking about the possibilities and the performance and the costs and things like that. So we thought we would provide an overview really for the UPS industry and the types of lithium batteries that are typically used for these products. So this presentation will show pictures of Eaton products, but the lithium vendors we use, as well as our competitors, very similar, and in many cases the answers to questions will be the same no matter where across the industry that you pose that question. Of course, battery is the most critical element in any UPS system, and we are now deploying lithium batteries even in small rack mount style UPSs to take advantage of the lighter weight, smaller size, better recharge times. And most of this presentation, though, will be about lithium technology for use in mid-size to large UPSs. So it should be understood that there's lithium choices available for almost any size UPS that you have. Now, on this slide, we talk about the slow evolution of batteries over many, many decades. And in UPS applications, which is probably mostly over the last 50 years, we have used almost exclusively lead-calcium batteries. Flooded electrolyte batteries and now valve-regulated lead-acid batteries are the most common technology in UPS use of any size. And by the way, valve-regulated lead-acid, we're going to abbreviate VRLA for most of the rest of this presentation. And for the last 30 or 40 years, we've been using this battery and hoping we had a more cost-effective, a more predictable, higher-performing, easier to dispose of solution right around the corner. But for the last 30 years or so, that corner hasn't really approached. There are alternative technologies. There's different battery chemistries. There's solutions like flywheels and fuel cells and even ultracapacitors. But the lead-calcium battery has always provided the best bang for the buck. That is, the best backup time for the dollar. And consequently, it's been almost the exclusive choice for UPS vendors. That is finally changing. So from the present and on into the future, we are now seeing a good acceptance and a good applicability of lithium batteries for both small and large UPSs. And on the right-hand side of this slide, you see some lithium packaging might be in the small cylindrical battery shape. Others might be in rectangular enclosures. And we're going to see in detail which technologies use the different packaging and what the advantages and disadvantages are. So here's a comparison of lithium technology versus traditional VRLA. Lithium's become a viable alternative primarily because it provides a longer service life and a longer warranty, and operates at excessive operating temperatures, has a higher cycle rate. What does that mean? It means you can do more charge-discharge cycles and still have the battery continue to function properly than we could with other alternative technologies. In addition, lighter weight, smaller footprint are huge benefits in any large UPS application where space is at a premium. So these benefits basically provide the lowest total cost of ownership. So if you look in this slide, on the left you see a footprint comparison with a typical VRLA footprint in pink compared with the lithium footprint in green. So 50–60% smaller, up to 75% lighter, but also with 2–2.5 times the service life and warranty. In addition, the higher operating temperature and large number of cycles. So if you look at the two examples of VRLA battery cabinets and lithium battery cabinets on the right-hand side, you see that both of those cabinets are the same capacity in terms of kilowatt hours. But the lithium battery always has a battery management system as opposed to a monitoring system, which adds a little bit of extra cost. There's also some costs associated with freight and shipping and installation services and things like that. But the raw cost for the VRLA versus lithium is close to being the same. Now, as little as 3 years ago, lithium batteries were many, many times more expensive than VRLA. But that's changed dramatically, especially in the last 2 years. Cost of lead has gone up a little bit, and the cost of lithium solutions for UPS has plummeted. So you could also see there the weight comparison and the square inch footprint comparison in that as well. So consequently, we have suddenly a large fraction of our client base basically demanding that we use lithium batteries because of these benefits. Some of them are still a little bit concerned about new technology and safety, and that's completely understandable. There's a few clients who said, we're not quite ready for a lithium solution. But we've been very surprised at the number of large clients who basically tell us that lithium is going to be their solution going forward. So as vendors in the UPS industry, we have all acted to get these products ready for market, and now they're available from all the major UPS vendors. Here is a vendor's description on the comparison of service life, and this is one of the big advantages. In valve-regulated lead-acid batteries, we've always budgeted for replacement every 5 years. You might get 6 years or maybe even a little bit more in a typical UPS application, but that was the exception rather than the rule. So if I had a large UPS system that might last me 15 years of life, I had to plan on replacing all the batteries at year 5 and again at year 10. Very expensive and disruptive to the UPS operation. So if you look at the chart here, where they look at the longevity of lithium versus traditional VRLA, you see that blue line going north very quickly there, and it's very good news for most of our customers here. But let's look closely at that before we go on. On the horizontal axis here, you see the temperature in degrees Celsius, and on the vertical axis, this is not years of life, it's something called a relative factor. So looking back at the bottom axis, I see that at 25 degrees centigrade, roughly room temperature, the VRLA relative factor is 1.0, and the lithium factor is about 2–2.5 times what VRLA would be. So that means if valve-regulated lead-acid were a 5-year battery, the lithium battery that replaced it would be at least 10 years of service life at that temperature. So lithium does have the ability to perform at very hot and very cold temperatures. However, it does impact its longevity. And you look quickly at the graph and say, well, look, the blue line says it's going to get even better as the temperature goes up. Well, let's look a little more closely. Let's pick a different temperature. At 40 degrees C, about 104 Fahrenheit, the VRLA battery, remember, this is relative factor of 1.0. So is a valve-regulated lead-acid battery a 5-year battery at 40 degrees C? No, it is not. It's about a 2-year battery at 40 degrees C, and lithium is 2 to 3 times more than that, which is good, but that's not 10 years. That's 2 years times 3, that's 6 years of lifetime for the VRLA battery. So if I do choose to operate a typical lithium solution in very hot temperatures on an annual average basis, I'm not going to have the full 10-year expected life. But if you look at the table over on the right, most of our lithium vendors are actually of the opinion, based on their research and their testing and their design, that it is quite likely that these batteries will last as much as 15 years in a UPS application, dramatically better than what we're all used to. However, typical warranties for lithium are in the range of 10 years, not 15. So I would cue off of the warranty information if you're planning service life on these batteries. So this information does come from a vendor, and be careful to read the fine print anytime you look at a brochure for this kind of a product. Now, what about storage of batteries? It's always been an issue with traditional UPS batteries that if I leave them in storage, especially in a warm environment, that when it's in the case of as little as 6 months, the batteries will self-discharge to the point where they are no longer useful or warrantable in a UPS application. So if for some reason my project was delayed and I had a battery that sat in storage for 9 months, there was serious question as to whether that battery would be useful. And this is much too big an investment to not be able to use it when you need it. So the lithium batteries do excel in terms of their storage capability. If you look at the chart on this slide, you see the open circuit voltage on the left, and the red line is basically the lower limit. I don't want the battery voltage to drop below that limit while in storage. And you look on the horizontal axis and you see the number of days. There's actually a couple of years of data here, both at 25 degrees C, that's the blue line, and 60 degrees C, which is the darker blue line or the black line perhaps on your screen there. So even at 1 year and up to 2 years of storage, you see we're nowhere near the red line limit there for a lithium battery that's put into storage at 100% capacity on day one. So that's very encouraging, but keep in mind two important things. Most lithium batteries, if not all of them for UPS use, are going to have a battery management system that will do a little bit of self-discharge of that battery over time and can discharge the battery fairly rapidly, closer to 6 months. Now, the batteries can be disconnected within the cabinet so that that does not happen. So, but if you have a battery that's connected in a cabinet and in storage, you should expect more on the order of 6 to 9 months of storage life rather than 12 months. The other thing to keep in mind is we have found, based on the regulations and the requirements from UN 38.3, that when we ship these batteries as an industry, they need to be shipped at about 30% state of charge. So they are not shipped fully charged, they are shipped at about 30% state of charge. Why do they do that? Well, it basically dramatically reduces any chance of a thermal event during shipping, which is good. But if I take a battery that's been shipped to my warehouse at 30% state of charge, then the open circuit voltage on that battery is going to start off a lot closer to the red line limit that you see here. And that alone is going to limit severely the amount of storage time that I can get. So yes, it is possible to store lithium batteries under the right conditions for a very long time. But make sure that you read the details and talk to your lithium vendor or your UPS vendor, which can clarify exactly what the storage time will be in your particular case. Now, the next slide covers different chemistry types for lithium. It's very common for folks to simply say, well, a lithium battery is a lithium battery. They're all the same. They're made by the billions for laptops and cell phones, should be very inexpensive, and that's what I want. And there's a little more detail to that, especially for UPS applications. There are several different lithium chemistries which have significant advantages and disadvantages. And on this slide, you see the white cabinet is a combination of two chemistries, one of them called LMO plus NMC. It's a combination of two lithium chemistries. The cabinet on the right is a lithium iron phosphate battery, and that battery happens to have the best safety performance of all the lithium chemistries, but as you can imagine, there are advantages and disadvantages beyond that. So on the left-hand half of this slide, we compare those chemistries on the basis of specific energy, which is the lines to backup time. Also, we compare on specific power, which is the ability to deliver high rate current for those short, steep discharges only of a minute or so backing up a UPS. Also, we compare on performance at hot and cold temperatures and lifespan. Not only how long will the battery life be, but how many times can I charge and discharge it without wearing it out. So if I look at the spider graph on the upper left corner here, we see the lithium iron phosphate, which is the safest chemistry, performs excellently on safety and also excellently on specific power, which is the ability to handle those high rate, super intense, but short discharges. On specific energy, which means long backup times, not so much. Cost is reasonable, lifespan is excellent. This is where you get the 10-year full warranty, and performance at temperature is very, very good. So pros and cons here. This chemistry is very safe, but it's a little better at the short, steep discharges than the long, slow discharges that we might see in a UPS application. The next spider chart there shows a lithium manganese oxide chemistry. And in the cabinet on the left, the white cabinet there, we combined that chemistry with lithium nickel manganese cobalt oxide. That's a lot of chemical names in a row if you're not a chemist. The most important chemical in there is oxide, because what that means when you see that in the chemistry name, it means that that battery has the capability to make its own rocket fuel. That's why lithium batteries tend not to burn like campfires, but like rocket engines. So we must be very, very sure that the batteries are operating safely and we do not get in a mode where a thermal runaway could occur. But the combination of these two chemistries gives us better performance than either chemistry by itself. So if you look at these two charts, you see the specific energy is quite a bit better than the other one we just looked at, which means longer backup times. Safety is good, but not quite as good as lithium iron phosphate. Lifespan is good. Cost is reasonable as well. So we do choose different lithium chemistries based on the application that the customer tells us they need. Now, what about the spider chart in the lower right? That one's great on specific energy, not so much on specific power, and it's good on performance at temperature, but not so great on safety. So where's that chemistry used? That lithium chemistry is what you find in your laptop and your cell phone and your hoverboard. Now, why? Well, those cases, those batteries have a requirement to fit in very, very small spaces and keep your cell phone running for up to 2 days without a recharge. So those capabilities actually exceed the need, frankly, for the super high safety that we're looking at in UPS applications. So it all depends on which lithium you choose and what your application is. So here's an example of a cabinet design using the lithium manganese oxide battery here. And this cabinet contains 16 or 17 gray boxes about the size of shoe boxes, and in each box there are 8 brick-sized lithium batteries. Also, you can't see here in the gray box is a circuit board underneath the cover of the box. It opens up like a clamshell. And on that circuit board, as you can imagine, you have communication and sensing, but you also have power transistors that act to regulate how much charge current this battery receives and make sure that the voltages are balanced between those batteries at all times. And if one battery starts acting up thermally or otherwise, the controls have the ability to literally bypass that one battery and leave the rest of them in the circuit. So there's a lot more management, not just monitoring of the battery system in any lithium-ion battery solution. What else do you have in the cabinet? Well, you've got a battery disconnect breaker and terminals to land your positive and negative DC signals going to and coming from the UPS. And in addition, you see near the bottom of the slide there, there's an SMPS assembly, which is actually the battery management system. And it does monitor voltages and currents and temperatures and voltage balance and things like that, but it also has the ability to control how the battery operates. And if that battery is not happy, the management system can simply disconnect either that battery or the whole cabinet and do it automatically and remotely. So if you think about this compared to your traditional VRLA, the thing that should come through here is that these batteries do not like to be ignored. If you put them in a room and forget about them and think they'll take care of themselves, well, they will. And if they're not happy, they'll simply disconnect. So it's a lot different than what we're used to with traditional UPS batteries. But it's all for safety, and that's a good reason. Here is a cabinet using the lithium iron phosphate battery, and if you look closely on the cabinet on the left, with the green batteries in the bottom, they look like automotive batteries. They're about the same physical size and shape. But the good news is they only weigh about 20 pounds instead of 50 some odd pounds, and each one is 24 volts. And inside each little green enclosure is a whole bunch of lithium batteries. These ones in the picture on the right say valence on them. That's the vendor. And these batteries are physically a little bit larger than AA batteries. So there's a lot of them in each green box connected in a series parallel arrangement to provide the 24 volts, and 20 of these batteries in a cabinet gives us the 480 volts DC that we need to support a UPS system or a typical large UPS system. And again, these batteries, like all lithium batteries, it depends heavily on how they're manufactured, but this is a very commonly used and recognized as a safe type of packaging for the lithium chemistry. This is the lithium iron phosphate solution. So how do we make sure that these batteries are safe? These batteries are a lot bigger than the one in your phone and the one in your laptop or your hoverboard. So what is being done to make sure that this battery never gets into a mode where it tries to get warmer than its ability to dissipate heat? Well, first thing you see is a vent. Now, this is not a fan in spite of the icon. It's a similar vent to what you might find on a valve-regulated lead-acid battery. If the battery is abused or overcharged, for example, the vent will open up and let out the internal pressure. And as you may know, the internal gases that would be emitted in that case for valve-regulated lead-acid are actually toxic. So the good news is that lithium batteries do not emit toxic gases. The bad news is they do emit flammable gases. So we want to make sure that this battery doesn't get in a mode where it has to vent. But there is a vent there if necessary so that it doesn't break the case. There's also an overcharge safety device. This is like a little bypass relay that's built into every single battery. So that gray box that had 8 batteries we saw on a previous slide, every one of those 8 has its own bypass device that's controlled by the management system. So if that battery starts to get a little warm, we're going to reduce the charge current to that battery and do it automatically. If it continues to get warm, we're simply going to bypass it so that it is no longer in the circuit. So effectively taking that battery out of the picture. In addition, each battery contains an internal fuse, so if our electronic controls fail and the current gets too high, the fuse will isolate the battery for us. And toward the bottom of the slide, you see things called a multi-layered separator design. This is basically just to ensure that the metal plates inside the battery do not saw through the insulators and contact each other. That's what would cause a thermal event. There's also a safety functional layer, which sounds just like marketing, but what it actually is a physical space all around the perimeter of that battery to make sure if it gets dropped, if the internal parts of the battery swell up, that it will not restrict itself against the insides of the case. This is the kind of thing that you do not see in cell phone batteries, for example, because there simply isn't space for that. But it makes a huge difference in terms of the performance of the battery at high temperature or under abusive conditions. So there's multiple things that we do in this industry to make sure lithium batteries remain safe, even in a high-intensity discharge or charge application. Along with that, the user does have monitoring software that comes with the battery. Here's an example from one of the vendors here. And you can see on the screen, this would be the screen of anyone's laptop that can connect to the battery cabinet either directly or over the network. The presence of the management system means that this kind of information will always be available no matter how the battery is purchased or deployed. But it allows the user to see lots of detail about the performance of the battery and the critical measurements. And along the left-hand side, which is a little harder to see, there's things that the user can adjust and look at historical information and even make a few basic settings. This does not give the user a whole lot of control over some of the detailed settings, which would be handled by a field service person, but it does give them a good view as to what's going on with each one of their battery cabinets. So the battery management system monitors the voltage of the battery at the cell level and the pack level. It performs balancing to make sure all the batteries are balanced within about 1/10 of a volt. This is one of the ways that we eliminate the possibility of over-temperature conditions existing. We monitor temperature, of course, and the state of charge and state of health of the battery, and provide alarm information both over to the UPS so that it can enunciate an alarm, and also independently over a network, maybe a Modbus network that might be used in a typical data center facility, for example. Who performs battery service? Most of these batteries are built overseas, or the batteries themselves are manufactured overseas, and our vendors do have services available locally here in the U.S., for example, but they do not have huge service organizations, and we are seeing a lot of clients procure and deploy lithium batteries. So from our perspective, we are taking over the service of the battery. We'll be helping with the installation, setting the battery system up, doing commissioning, testing, and also we, as the UPS vendor, would be handling preventive maintenance and corrective maintenance if there's a problem in the field. We do have access, of course, to the vendor for technical support and even for on-site support, but it is a limited number of people available, so we want to make sure we have the right number of feet on the street that we can handle any client's needs and do so instantaneously. So in many cases, you'll see the UPS vendor performing the service on their lithium battery, at least in these early years of these types of deployments. Agency requirements. This comes up very, very frequently because this is a new technology entering the data center or entering the facility. So the authority having jurisdiction, the electrical inspector or the engineer or the agency person is going to have a lot of questions. Does this battery meet in certain standards? What do I need to do for fire suppression, for example? What do I need to do about toxic or flammable gases? How much ventilation do I need? Well, fortunately, UL and the National Electrical Code and the Fire Code have developed standards, or in final development of standards, as we'll see in a slide or two, to handle lithium batteries. And the good news for all of us is it's not as much different from traditional VRLA batteries as you might expect. So on the left-hand part of the slide here, you see some of the UL requirements that all of our lithium vendors have listed to or certified to: UL 1642, UL 1973, a couple of other standards for testing and safety-related controls. But the most important one, in my opinion, is down at the bottom, UN 38.3. That's UN as the United Nations. The United Nations, in fact, sets the standards and requirements for the transportation of these types of batteries. And that's good because it gives us a worldwide set of guidelines, and mostly it describes the packaging and labeling of the batteries so that transporters understand what these are, what temperature limits they need to be held at, etc. But this is also where that requirement comes from to ship batteries at 30% state of charge or less. So unlike VRLA batteries that we could ship at 100% capacity, if they're going to be transported through the air or even over the ground, needs to be done at 30% state of charge. And again, the reason for this was the FAA did testing and found out unequivocally that at a lower state of charge, the chance for thermal events is dramatically reduced to the point where it becomes very, very safe to transport those lithium batteries. What's the downside of that? I receive a battery that's 30% charged. When I put it in play on the UPS, I'm going to need to wait a while, typically 2 days, for the battery to fully charge up before I can do a comprehensive test on that battery. And remember that if I go and put that battery immediately into storage at that low state of charge, the amount of time that I can keep it in storage safely is much, much less. The next slide here shows a draft of the newer version of the IFC, the International Fire Code, that's going to come out along about, I believe, July of this year. So this is not set in stone, the information you see on this slide. This is a draft just provided to give us an idea of what we're going to need to comply with for lithium installations going forward. And fortunately, there's not a lot of dramatic change. Much of this reads like Section 608 that you may already be familiar with in the IFC. So for storage of the batteries, if you look on the right-hand side of the slide, except for the levels of energy, lithium is treated pretty much the same as lead-acid batteries in terms of safe storage. And below that, you see that lithium-ion and lithium metal polymer batteries shall not require additional ventilation beyond that which is normally required for human occupancy of the space. So those are good news items. And if you look at the bottom of the slide, you see the capacity is listed in kilowatt hours. That's a little different than we're traditionally used to thinking of battery capacity, but it does apply to all the different types of battery chemistry, valve-regulated, lead-acid, NiCads, lithium, and others. So there are capacity levels at which the fire code requirements may change, especially in large installations. And I think the next slide will show us that, for example. This next slide is titled Maximum Allowable Quantities, and this is the quantity at which I need to switch my room to a more fire-resistant room with fire-rated doors and windows, and excuse me, and also fire suppression systems get more complicated at that point. However, if you look in the fine print in the table, it says lithium, all types, the maximum allowable quantities is 600 kilowatt hours. Now, each of the battery cabinets that we saw on the previous slides are about 33 kilowatt hours. So I would need to have a lot of lithium battery cabinets in the same room in order to have to move up to group H2 occupancy, which is the one that has the more stringent fire suppression and fire reduction requirements. So this information will be publicly available in July. But remember from the previous slide that all the lithium vendors that we're seeing in the market already meet the UL requirements for both the deployment of this battery as single batteries and as large battery strings and cabinetized environments and that type of thing. So there will be some questions and answers and some uncertainty in these early years of deployments, but the good news is all of the vendors, including the UPS vendors, are making a lot of progress towards distilling these down to a reasonable set of requirements that the authorities having jurisdiction can consult quickly and say, okay, this is good enough, or it's within the limits, or it isn't. We want to try to limit the confusion, obviously. Here's an example of a UPS runtime chart for a medium-sized UPS, and I know this is a lot of numbers to look at, but here you see across the top of the chart in this medium-sized UPS, let's say under 200 kVA, you can go up to 8 battery cabinets and get reasonably large amount of battery backup times, almost up to 3 hours. If you look at the lower left corner of this table, you notice there's a bunch of blank spaces underneath the shortest run times. So the question that comes to mind is, where's my 5-minute battery? Where's my 4-minute backup time? Where's my 3-minute backup time? Well, you can do that, but it turns out that if I try to do it with a minimum of number of cabinets, the discharge is so intense that the temperature rises too quickly and the battery will automatically disconnect itself. So if I need a 5-minute discharge, I probably would need to buy about 8 minutes worth of battery in order to make sure I can do that short of a discharge at that high current without over temperature. So we can configure batteries for that time if you'd like, but it tends to be sometimes less expensive to look at an 8-minute battery rather than a 5-minute battery, just based on the amount of cabinets that would be needed. So consult with your UPS vendor or your battery vendor to make sure you have a proper sized battery. Now this next slide shows an example of some of the testing that we did on one of our lithium cabinets here, and we have lots and lots of this type of information, but I won't subject you to it right at this moment. Just as an example, though, this one shows the same battery being discharged with 2 different load levels. So in one case, we start off with the battery cabinet 100% charged, load up the UPS to 180 kilowatts, and if you follow the red line here, this is the battery voltage as it discharges down to cutoff at about 9.5 minutes. Good performance, actually, for a single cabinet battery in this case. And then power is returned, and you see the red line continue to slowly increase as that battery recharges. Now, once the battery does recharge, we discharge it again, but now at only 56 kilowatts on that battery. This time we're following the blue line, and you see that it discharges very, very gradually over time. The cutoff voltage, the little V-shaped notch in the curve, is at the same point as it was on the red curve, about 410 volts DC on a 480-volt battery. But we're talking about 33.5 minutes of backup time at that lighter load. This is not dramatically different from the performance of a VRLA battery. And if you look at the other 2 lines on the chart, the state of charge of the batteries you see for the longer discharge, we were able to discharge that battery to a lower state of charge before we had to cut off. And again, this is very common to what you're used to with valve-regulated lead-acid batteries, which is good. We don't want to perform too differently because it would induce quite a bit of confusion in the field. Lots of this testing has been done. Here's another example of a larger UPS system, say a 1 megawatt UPS with 12 battery cabinets in parallel, 12 strings in parallel, is looking at 19 or 20 minutes of backup time. We can go longer than that, but we do have physical limits typically as to how many cables we can pull in to the UPS system or to a junction box. So again, consult with your UPS vendor. We have lots of flexibility and can usually meet your backup times needs for a very reasonable price. Heat rejection. This question comes up occasionally, And we should first say that when the batteries are charging, there is a limit to the amount of charge current that we're allowed to provide with the UPS, and consequently, the amount of heat generated during charging of a discharged battery is almost negligible, barely detectable. But what kind of heat are we giving off during a discharge? Maybe my discharge is 1 hour, maybe it's 15 minutes, maybe it's 5 minutes, but during that time, the system will emanate heat, not much different than valve-regulated lead acid, but as you see in this particular case, on the far right of the table there, about 8,900 BTUs during the time that that battery is discharging. And that's a worst case condition. That's a battery that's discharged at full load for the full amount of backup time. So typically not enough to impact the air conditioning of the room, as long as the air conditioning in the UPS and battery room remains functional during the discharge and doesn't shut off due to the generator not starting or the air conditioning not connected to a generator, those kind of things. But generally, there's no concern about heat rejection with a lithium battery above and beyond what we would normally do for a valve-regulated lead-acid battery. Now, the next two slides are some frequently asked questions, and as soon as we do these, we're going to throw it open for questions that you guys can pose. The first one here is, do UPS vendors really have experience with this in a data center application? And the fact is, yes, ourselves and the other top 4 or 5 vendors have been testing and shipping and deploying lithium batteries for at least the last 2 years in different varying quantities depending on vendors. Most vendors have lithium installed in hyperscale, multi-tenant data centers, in data centers that are intended for backup of financial institutions, and even non-standard applications like aerospace data centers. And they have performed really flawlessly in just about every single case. One of the things we've noticed as we tested lithium batteries from various vendors is that they tend to exceed their specification performance and backup time and safety by a healthy margin, and that's quite impressive to us. Which UPS systems are compatible with lithium batteries? Can I throw them on any UPS out there? Better check with your vendor. We do need to regulate the charge current to the lithium batteries very closely, and some older UPSs may not have the ability to limit the battery charge current. The battery charge current might vary with the load on the output of the UPS. So not all older UPS products will be compatible, at least not at the start. So do check with your vendor before you deploy a lithium battery with the UPS. And generally, we're going to need to make some minor changes to the firmware in the UPS to control that charge rate and set the cutoff voltage and those types of things, but very minor modifications to firmware and can be easily done on site by any field engineer. What about recycling and disposal issues? This is a very, very common question. Almost every client asks about this. Is it possible to recycle these batteries? What do I do when they reach the end of their life? Hopefully that's 10 years down the road, but I still want to know how that's done. It is possible to recycle lithium batteries similarly to what they do with lead-acid batteries, and under the high heat conditions when the battery is disassembled and heated, the lithium literally floats to the top as a foam and can be skimmed off and disposed of safely in that case, or even possibly reused. Now, we should say that in the UPS industry, none of us have been doing this for more than 10 years, so we don't have a whole lot of experience with lithium-ion recycling. The automotive industry probably does, because they've been making lithium-backed up electric cars for some time. But we, like other vendors, have recycling vendors that handle our recycling needs, and they are available to recycle small and large format lithium batteries. You simply dial the 800 number and find out where to ship the batteries, and they take care of it from there, of course, for a fee. So they may not be readily recyclable, but it is possible. One of the things to keep in mind is most of the lithium battery vendors are asking us to return spent batteries to them, because the end of a UPS battery's life is typically defined as when that battery can no longer produce 80% of its original capacity. But in the case of a lithium battery, that doesn't mean the battery is completely useless at that point. For example, we have an arrangement over in Europe where we take used batteries from electric vehicles that have exhausted their service life in an electric car, and we put them in application, for example, using emergency backup lighting for commercial buildings, and we are seeing an additional 6 years of service life on those same batteries that were exhausted in an automotive application. Same kind of things can be done with UPS batteries, so keep in mind that they don't have to be recycled or disposed of at the end of life. There may be a possibility for a second life application, and this brings up a whole new dimension to the green and sustainable nature of this technology. Next question here. Can lithium be mixed with other types of battery chemistries like valve-regulated or NiCad or lead antimony? The answer is no. I don't want to put them in the same string or in the same parallel string with a different chemistry. And this is pretty much true for most battery chemistries. You really can't mix and match, at least not in a UPS application. Next slide. Can the lithium battery ship internal to the cabinet, pre-wired and ready to go? And the answer is depends on the vendor. Some vendors have passed the UL testing that allows the batteries to be shipped connected inside the cabinet with certain safety precautions. Other vendors are in process with that and will ship the cabinet empty and a pallet of batteries next to it. Keep in mind that generally they're going to be shipped at less than 30% state of charge regardless of how they're packaged. Can we airship batteries or lithium batteries? It is possible, but of course it's costly, and many UPS vendors are handling it such that battery cabinets or completed battery systems will ship over the ground, but replacement batteries that need to be on site in a hurry can easily be air-shipped. Keep in mind the state of charge limitations, so I'm going to have to take a little while to bring my new battery up to charge with the rest of them in my system there. So a little bit different than valve-regulated lead acid in that case. Does the battery management system have to be powered on even while the battery is in storage? Answer is no, but keep in mind that the battery management circuitry may act as a parasitic loss on all the batteries that are connected in the cabinet, and we don't want to self-discharge them too rapidly or it might impact the warranty. Now, what do I do if I have a battery failure in the field? I've installed a battery system, it's up and running, maybe it's ran for a couple of years, and all of a sudden the management system tells me, hey, battery number 6 is bad. What do you do? Well, just like VRLA, you call the UPS vendor. We all have processes similar to the processes we use for valve-regulated lead acid, and we can provide on-site service to come out, remove the defective battery, replace it with a new one, and get you back online and get everything balanced up and good to go. So the answer, if a battery fails in the field, is to call the UPS vendor. We all will be using our own service organizations to provide the feet on the street to handle this, and we and our competitors have lots of field engineers that are trained to both handle the troubleshooting as well as the shipping and replacement of these lithium batteries. So we are good to go as an industry on that. Okay, so a quick summary here before we open it up to your questions. This summary slide here just gives us a recap of the advantages of lithium compared with traditional lead-acid UPS batteries. So system space as much as 30% less, that's a best case condition. Shipping weight, as much as 60% less. Design life goes from 3 to 7 years to maybe 15 years with the lithium battery. Keep in mind, the real question is, what is your warranty, Mr. Battery Vendor? The operating temperature, as high as 40 degrees C. Keep in mind, if you want the full 10-year warranty, you will keep it at a temperature considerably lower than 40 degrees C. Battery management system is always built in. It's not an option. You have to have that, and that's primarily for safety reasons. The best reason that lithium batteries are safe has nothing to do with the battery itself and everything to do with the battery management system that's included in every lithium system. If you look at the environmental picture from the fabrication of the battery on through its service life and the disposal, the lithium-ion battery is actually quite a bit more green and sustainable solution than any lead-acid battery that we've ever used in a UPS application. So that takes me to the end of my discussion here, but we do want to go ahead and open it up for questions from anyone. We'll be glad to take any question that you have.
Thanks, Ed, for a great presentation. Okay, let's go to questions. What care do you have to take with the battery system, and what preventive maintenance is performed?
That is actually a good question. I've got a battery now that has a management system that does a lot of the caretaking for me. So could I get away with fewer battery maintenance visits, for example, over its life? And the answer to that question may be yes, but because this is new to all of us, UPS vendors and battery vendors as well, it's our plan, and most of our competitors as well, to treat these batteries from a maintenance and corrective maintenance standpoint, preventive maintenance standpoint, very much like we do valve-regulated lead acid. So for the time being, especially in these early years, we're planning on visiting these batteries physically on site at least twice a year and doing the things we would do for a valve-regulated lead acid battery. Check the impedance, check the performance, check the terminal connections and make sure they're not corroded or maybe need to be retorqued. Those kind of things, taking measurements, are what we'll be doing for the foreseeable future manually and with the same frequency that we do for traditional UPS batteries. Now, maybe in 5 years or even 3 years when we have more experience, we'll be able to say, hey, you can cut back on the number of PMs that you do for these batteries, but that is yet to be determined.
Okay, let's see. Ron asks, the fire code requires 3 feet around each enclosure of a certain max kilowatt hour. That makes it tough to save space. How much how many kilowatt hours can fit?
Good question and a good point. And again, we haven't seen, keep in mind, we haven't seen the final version of the IFC code, but what the preliminary version indicates is that if I have a given enclosure that is less than 70 kilowatt hours, I don't have to maintain those space limits. And fortunately, most of the lithium batteries that we've seen for this application are in the low to mid 30s kilowatt hours, so it's okay to put them side by side, back to back up against the wall, etc. But if you do find yourself deploying a lithium battery that is more than 70 kilowatt hours, then you may well be subject to that spacing requirement, and that would obliterate any of the space savings that you would otherwise have.
What is the proper design to vent the flammable gases out of a room?
Fortunately, we're able to use the similar ventilation that we would for a typical human-occupied space until the total quantity of lithium in the room exceeds 600 kilowatt hours. And that sounds like a lot, but we do have some clients that use a lot of UPS and a lot of long-duration batteries. And in that case, a positive pressure ventilation system with controls on the fans and controls on the UPS and battery charger would all have to be put in place similar to what we see with large valve-regulated installations. That means that the room is going to need a fan system, ventilated system that runs all the time, also backed up by the UPS. If a ventilation fan fails, the UPS should be then commanded to stop charging the battery so that we don't add any chance of extra gases building up in the room, etc. Keep in mind, though, that this, like VRLA, is a battery system that's made to remain sealed as long as it's not being abused or overcharged. So in typical applications, if the temperature is maintained properly and the UPS battery charger is functioning properly, those batteries will not vent anything. But there's always the chance that something could go wrong, so a ventilation system is going to be required in only the largest VRLA installations, to the point where I may want to set up the room such that I don't ever exceed 600 kilowatt hours in any one room, but divide my battery amongst multiple enclosures or multiple battery rooms to make sure that I don't have to spend a lot of extra money on both fire suppression as well as ventilation.
Okay, let's see. A lot of questions coming in. Can you install lithium batteries in the same room as flooded lead acid batteries?
Another excellent question. I myself didn't see this as being a possible issue, but in looking at the fire code requirements, that is one thing that they are very strict about. If you have multiple battery chemistries existing in the same physical room, there are much stricter limits, much lower limits on how much battery you can have. So, and this is not an uncommon thing. So if you have a system or an arrangement on your site where I may have valve-regulated or flooded lead acid batteries and I want to put a string of lithium batteries in there as well, check the fire code, because the limits as to how much you can put in would be severely restricted. You can certainly deploy that battery in a separate room, but if I'm going to put them in the same room, different chemistries in the same room, the limits are significantly lowered.
Let's see. Okay, is the BMS a standalone system, or can it be integrated into an existing building automation system?
Generally, it's a standalone system. However, all the ones that I've seen and all the ones that I've seen on the market have the ability to communicate with the building management system as simple as via relays, but more likely by an industrial protocol like Modbus or BACnet, the typical types of protocols that you would see in a battery management system. But if all I need is a signal from the battery that says I'm okay, I'm not okay, that could be done with something as simple as relay contact or dry contact signals, and those options exist. I say options, typically standard in every lithium battery system. I can also monitor the UPS, which is receiving signals from the battery system, and use the same monitoring Modbus or SNMP or whatever that I would use to monitor my UPS system on the network, and I would get battery-related alarms and conditions and status via my connection to the UPS. So there's lots of choices.
What is the maximum storage temperature for the batteries?
The maximum storage temperature that I've seen in specifications has been 60 degrees, but I only have a couple of different vendors to compare against. But for storage temperature above 60 degrees C, I have not seen any vendor that advocates any higher than that.
Let's see here. Is the lithium battery fail gradual over time where you can predict a failure?
In our experience, yes. Just like valve-regulated acid batteries, we're looking generally for that 80% capacity point, and it does gradually roll off over time. So it's not the kind of thing where I'll be at 70, at 85% capacity for 9 years, and I'll lose that last 5% in the 10 years or the 10th year. It is a gradual roll-off. However, the preliminary data that I've seen does not show much, if any, degradation, for example, in the first 5 or 6 years.
Do you recommend installation of these type of batteries inside the same room that contains a generator?
Don't see any problem with that as long as the ventilation requirements for the generator are met. And also you do want to keep an eye on temperature. So maybe the generators are running during an environmental event for a week, for example. Is the heat going to build up in that room where it might get too warm for the batteries? But again, these batteries do better at higher temperatures, certainly in short term without significant damage than traditional UPS batteries. But you do not want to ignore the temperature limits or subject the battery to extended high temperatures, because it will impact their 10-year service life.
What is the main feature that makes a lithium battery safe?
The main feature that makes it safe is the battery management system. Now, there's other mechanical things that we do basically to make sure that the battery plates never short together. Use a high-strength separator, put a barrier around the perimeter of the battery in case it swells or gets dropped. But the battery management system basically ensures that that battery will not get itself in a position where it generates more heat than it can dissipate. That's the definition of thermal runaway. So the battery management system ensures 24/7, 365 that that battery can always dissipate more heat than it creates. As long as you do that, you will not have a thermal event.
Are lithium batteries Canadian UL certified or CSA certified?
What we've seen is UL and Canadian UL. They may be CSA as well, but I don't remember actually seeing that.
Should I consider a lithium battery which does not include a battery management system?
I would recommend against that, because in my experience, I haven't seen one that makes me feel at all comfortable about safety with no management system.
What kind of thermal overload is in this battery, and what conditions does it show before it fails?
So what will happen is the battery, of course, as it begins to get too warm. Why? due to possible overcharging, or maybe the ambient temperature got dramatically hotter for some reason while the battery was charging. So when we start to see a battery or a battery cell that is getting too warm, the management system is going to take action to reduce or even turn off all charge current to that particular battery. So it can do that on an individual basis, which is good, allows the rest of the battery to continue to function. However, if we take those steps to reduce or disconnect the battery charge and that battery continues to get warm, remember we're watching the temperature of every single battery as well. So if it continues to get warm in that case, we are simply going to bypass that battery and effectively disconnect it from the string. We're going to jumper around it, so to speak. So the battery will generate alarms throughout that process. It's going to say, hey, I'm a little warmer than I should be. A few minutes later, I'm still too hot, and the automatic protections have gone into play to reduce my temperature, and if the temperature continues to climb, at that point it'll give a signal that says, hey, I have disconnected myself from the string. And by the way, if this should happen with multiple batteries in the same cabinet, the entire cabinet will automatically disconnect by opening a contactor or by shunt tripping a breaker. And in the case of the shunt trip breaker, the user will have to come to that battery cabinet and physically reconnect before that battery can be used.
How does the discharge curve differ from VRLA batteries?
It's similar in many respects, but one of the things that we have not seen, interestingly, is the lack of the coup de fouet, which is French for the crack of the whip, where a typical UPS battery will discharge very suddenly and very deeply for the first few seconds after the power fails, and then they'll recover quite quickly and then continue their long, slow discharge rate over the 10 or 15 or 30 minutes that the battery is intended to discharge. But you have to watch out for that coup de fouet to make sure that it doesn't drop low enough to cause the UPS to disconnect. In lithium battery testing, we have not seen that phenomenon. So that's a little bit better in terms of reliability of operation and gives us a little bit of flexibility in how the whole battery system is sized. Other than that, discharge curves look pretty similar.
What are the main safety preparations I should make on site before installation?
You want to make sure that in your battery room you'll not be exceeding the total amount of lithium capacity in kilowatt hours as defined by the fire code. And again, like we mentioned before, I want to make sure that I'm not mixing in one room several different battery chemistries because the limits for capacity would be reduced in that case. If I'm just deciding to deploy lithium batteries in a storeroom or spare room, there's things actually that I don't have to do. I don't necessarily have to have special ventilation at reasonable size levels. I can recycle that ventilated air back into the room, which is something we typically don't do with flooded electrolyte batteries, or we're required not to. Don't necessarily need, at least at this point, the code hasn't specified anything about explosion-proof lighting fixtures and lighting switches and things like that until you get above 600 kilowatt hours, which would be a very, very, very large number of lithium batteries all packed in the same room.
Okay, we have time for one more question. Are there environmental compliance issues as with lead-acid batteries?
I think this is a point that's generating and going to continue to generate considerable confusion because most electrical inspectors and engineers and even end users think of a battery as something that you really can't get away with going out and throwing it in the dumpster because it does contain toxic materials, not the least of which is lead and sulfuric acid and other unpleasant things like that. However, lithium batteries generally, or not generally, but they do not contain toxic materials, but it does make better sense to recycle them just like we do lead-acid batteries so that I can recover the plastics that make up the case, some of the metals that make up the lead plates and the terminals and things like that. That actually makes it a better idea to recycle rather than simply to dispose of. And then the lithium itself, I do want to collect in a recycling process. I may be able to reuse it, or at least I can dispose of it, or the recycling vendor can dispose of it in an environmentally prescribed fashion. So these questions are going to generate quite a bit of confusion on site. But talk to your UPS vendor, and if there's a question they don't know, they can, of course, communicate directly with the battery vendor and find out the latest information for you. And it's a good idea to do that frequently, because one of the things we've noticed over the last 2 years especially is these regulations are changing sometimes almost monthly in terms of limits and what's allowed and what's not allowed, et cetera. So the answer may change over time, especially in these first few years in UPS deployments.
That's all the time we have for questions today. Please join me in thanking Ed Spears for his presentation, as well as our sponsor, Eaton. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. As you exit today's webinar, please take a couple minutes to complete our survey. We strongly welcome your detailed comments. Please visit webinars.missioncriticalmagazine.com for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you have found this webinar to be a valuable experience.